In this video, we're going to unlock the full potential of your Arduino by mastering non-blocking code with the millis function. We'll cover everything from delay versus millis, resetting millis, multitasking with millis, countdown timers, and handling the millis overflow. So let's dive in and learn how to master millis on Arduino. Okay, so now first I want to explain what the millis function is for. And so basically what the millis function is for is counting time of how long the Arduino has started. So basically right when we plug the Arduino in and it starts running, the millis function will start counting the time ever since we have started the Arduino. And so we know how long the Arduino has been running. And so with that, we can figure out when was the last time we read a sensor and when should we read it again. How long ago we blinked an LED, so we know when to blink it again. Basically, that's what the millis function is for, so we know what times we should do specific things. And so basically that is what the millis function is for. And so here we have right here a simple little sketch. This sketch is going to be showing us the millis function in action of, start counting up time on ever since the Arduino has been running. So first thing we do here is we set up a serial monitor because we put that time out constantly in the serial monitor. And then we're going to go into the void loop and we're going to do serial.println millis. So all you have to do to get the millis value, the value of how long the Arduino has been running, we just have to call the millis function and it will give us that. So we just put millis in the print brackets right here and that should print it. So now this should just be constantly spitting out of how long the Arduino has been running. So we're going to go ahead and upload this code. So now it's uploaded, so now we can go look at the serial monitor here. And as you can see, the time in milliseconds is starting to rise. So right now it's 4 seconds, 5 seconds, and this is time we just constantly keep on counting up. So this number can get large very, very quickly. So as you can see, we have 8 minutes, the Arduino has been running for 20 seconds, now 21 seconds, it's going to keep on going up. So now we know how long the Arduino has been running, and it does this in the background. So your Arduino can be doing other things while this is running, and whenever you want to check how long the Arduino has been running, you can just call the millis function and figure out how long the Arduino has been running. What the difference is with the millis function and the delay function is that the delay function, whenever let's say we're trying to blink an LED, basically what it does is when we do the delay function, we have to stay and wait. The code is not going anywhere else. It's not going line by line, keep on going, doing other things of code. It sits there and it waits until the proper amount of time of that delay function has passed. But with the millis function is we can set a time, like, okay, let's say we are at 5 milliseconds right now since the Arduino has started. We turn on an LED. We say, okay, we're going to wait till like 10 seconds. 10 seconds ever since the Arduino has started, and then we come back and turn off the LED. So we just wait till that time the millis function reaches 10 seconds, and then we come back and turn off the LED. This just helps it so that the code is not blocked. We can be doing other things while blinking this LED. And so that's what the difference is with the delay function and the millis function. And so to make this easier to understand, we have this code right here, and this code is basically blinking an LED, and also we are incrementing this num value right here. And it's incremented in 1, so every single time we loop this function, it should be incremented by 1. So it's going to start with at 0, and then 1, 2, 3, 4, it's going to constantly go up. And so what we do here is we define our pin 13 right here, and we put that into the variable LED. So put the value 13, which represents pin 13, into the variable LED, and then we define our num variable, that's going to be an integer, and make that equal to 0. And so then we go into our void setup, and we do pin mode, LED output, which means that the pin 13 is going to be an output, which is pin 13 is connected to the LED. And so then we define our serial monitor because we're going to be using that, and we're going to be setting it to 9600 baud rate as always. And so then we go into our void loop, and we go ahead and do digital write LED high, basically turn it on, and then we wait 500 milliseconds. So we're going to sit here and wait 500 milliseconds until we go to this next line of code. Okay, and so then when we come down to this next line of code, we turn the LED off, and then we wait another 500 milliseconds. And so basically, we're gonna go ahead and blink this LED, and to basically finish all of this code, since these delays are here, it's gonna take 1 second to pass all of this code right here. So this code down here is only gonna be ran 1 second every single loop. Okay, so we may want this code to go faster, but the problem is these delays are blocking the rest of the code down here to be able to run it until these tasks are done. And so basically, let me explain that. We'll go ahead and upload it. And so then we go ahead and open up our serial monitor. And as you can see, it's printing out the value in the increment, and it's print out num as it's counting up. And you can see that it's doing it 1 second at a time. But we may want this to print faster. We can't do that. We can't make it go any faster unless we turn down these values right here. But if we want the LED to be blinking this speed all the other code is going to be going that speed as well. But we may not want that. We may want to be able to do other things while it's blinking this LED. And so what we're going to do is we're going to use the millis function to make the LED to be able to blink, meanwhile incrementing the num value. And so let me show you that now. So now we'll go ahead and start explaining the code. And so the first thing we do here is, of course, we put the value 13 into the LED variable like we did last time. We defined our num value, and then we define LED state, which is going to be a Boolean value, and we'll set that to false because the LED state is going to be showing if the LED is on or off. So right now we want it to be off, and so we're going to want it to be a false. And so then we have unsigned long variables here. This is going to be a DT. This is basically how long the LED is going to be blinking, and so we want it to be turning on every 1 second and then turn off every 1 second. And then we have this unsigned long variable, and it's going to be the last action. So this is going to be the last time we have turned on or off in the LED. And something I need to tell you is that the millis function, whenever it gives us, amount of time, how long the Arduino has been running, it gives us that value in unsigned long value. And so whenever if there's any variables or any numbers we're working with the millis function, or any data that came from the millis function, we have to have it be an unsigned long. So we are making these variables unsigned long variables as well, because we are going to be storing, this one's going to be storing the value that millis function is going to be giving us. So that needs to be an unsigned long. And the DT is basically how long we want to wait to blink the LED. So we are going to be comparing the DT variable with this variable, and so this variable also needs to be unsigned long. And so then we come to the void setup, and we just define our LED and set up our serial model, and then we go into the void loop. And so basically we come in here and go into this statement, and we say if millis, basically the millis value is giving us how long ago the Arduino has started in milliseconds minus the last action. So basically what we're doing here is last action is going to be 0 at first. Okay, because we made it equal to nothing up here, so it's going to be equal to 0 by default. And so since it's going to be equal to 0, we're going to be taking 0 away from millis, basically amount of time that the Arduino has been running, so nothing's going to change the millis value. And so if that value is greater or equal to dt, basically if millis equals 1000 milliseconds, basically 1 second, then come into this if statement. And so then if LED state, we're just saying if LED state, basically if LED state is true, basically if the LED is on, then come into this if statement and turn the LED off. Then make LED state equal to false, because now since the LED is off, we want to make it equal to false. So then if this is not true, basically if it's off, then else we want to turn it on. Then we turn LED state true because the LED is on. Then after we're done with this, pretty much done with this if statement, then we set last action equal to millis. Basically the last time we have done anything with the LED, turn it on or off, we want to make that equal to millis. So this is the last time we have done something with the LED, so that we know when was the last time we got in here, so that we can come back in here later on when the proper time is ready to turn back on or off the LED. So let's say now that last action is now equal to 1000. Then we come back up here and we run this code again. So now last action is equal to 1000, since we come in here and we made last action equal to millis, which is 1000 milliseconds. So now we come in here and millis is now equal to 1100. And so we're going to take away 1000 from millis, that is equal to 1100. So basically what's going to be left is 100 milliseconds. So this is going to give us the value of how much time has passed ever since we have gone into this if statement. So then after we figure out how much time has passed since we've been in this if statement, then we're going to see if it's greater or equal to dt. Basically if it's greater to 1000 milliseconds, then we need to come in here because 1000 milliseconds have passed, and so we need to come in here and turn on or off the LED. Hopefully that makes sense. But what this is going to do is this is going to blink the LED. It's going to turn the LED on, wait 1000 milliseconds, then turn off, and then wait 1000 milliseconds, and turn back on, and then continue going while it's incrementing this num value. Okay, so it's going to be constantly incrementing this num value as fast as it can. And so we're going to see that. So we're going to go ahead and upload our code. And so now it's uploaded, so now we can go ahead and go to our serial model, and as you can see, the num value right here is incrementing really, really quickly. Meanwhile, this LED right here is blinking. On pin 13, that LED is connected to pin 13. It's fully blinking, turning on and off in 2 seconds. And so it's doing that. Meanwhile, the num variable is constantly rising really, really quickly. And so yeah, that's multitasking. It's able to blink an LED while it's doing something else at the same time. And so now we're going to go ahead and we're going to be blinking 2 LEDs at the same time but they're blinking in different speeds. This would not be possible with a delay function, but it's possible with the millis function. So let's go ahead and set up the circuit for it, and then we're going to look at the code. Okay, so now here's the circuit that we're going to be using to demonstrate how we can blink two LEDs at different speeds with the millis function. And so as you can see, we have two LEDs right here that we're going to be blinking different speeds. One LED is going to have the anode side of it connected to pin 13. The other side, the cathode pin, is going to be connected to a 330 ohm resistor that then is going to be connected to the ground rail on the breadboard. Now this resistor can be anywhere between 220 ohms up to 470 ohms, anywhere in between there. You could pick a resistor anywhere in between there, be just fine. And so then we have this LED that's connected to pin 12, the anode side is connected to pin 12, and the cathode side is connected to a 330 ohm resistor, which is then connected to the ground rail on the breadboard. And then the ground rail altogether is connected to the G&D pin on the Arduino. So basically that is the circuit. So now go ahead and connect that up, and then we are going to continue. And so now we connected up our circuit, and so now we can go ahead and look at the code. And so as you can see, we define pin 13. Just put the value 13 into LED 1, and then we put the value 12 into the variable LED 2. And so then we have two Boolean values, and this is the Boolean value for an LED 1 state. So this is the if LED 1 is on or off, and so I'd first want LED 1 to be off, so we'll make it false. Same here, this is the variable that we hold in the true false value if LED 2 is on or off, and so at first we want LED 2 to be off, so we'll make that as false as well. So then we have an unsigned long, and then we have LED 1 DT. So this is how long the LED 1 is going to be turning on, and then it's going to be turning off. So it's going to be turning on for 250 milliseconds, and then it's going to be turned off for 250 milliseconds. So then we have another unsigned long, and this is LED 2 DT. DT stands for delay time. And so basically it's LED 2 delay time, but DT is just for short. And it's going to be turning on for 1000 milliseconds or 1 second, and it's going to be turned off for 1 second. And so then we have another unsigned long, and this is LED 1 last action. This is basically the last action we have done with the LED. If we have turned it off or on, what was the last time we have done something with LED 1? So the time in milliseconds that we have done something with LED 1 is going to go into this LED 1 last action variable. And it's also going to be an unsigned long because we're going to be putting the value that we are getting from the millis function into this variable. So it needs to be an unsigned long. Same with these, because we're going to be comparing them with the value that we are getting from the millis function. So we need them to also be unsigned long variables, because if they're not unsigned long variables, then it's going to mess things up. Then when we have no unsigned long variable, and that's going to be LED2 last action, it's going to be holding the amount of time, the last thing we have done something. So it's going to be holding the time milliseconds on when the last time we have done anything with LED2. And so then we go ahead and go to the void setup, and we define our LED1, which is going to be an output. Then we define LED2, which is going to be an output. Then we go ahead and set up a serial model. So then we go ahead and go to a void loop, and we say if millis, basically if the value of how long the Arduino has been running minus LED1 last action. So basically, the last time we've been in this if statement, the last time we've done something with the LED, turned it on or off, we take that away from the millis value, and the leftover time we get is how long since we have done anything with the LED1. So if that value is greater than or equal to LED1 DT, then we need to go into this if statement. And so basically, if we haven't done anything with the LED since 250 milliseconds, then we need to come into this if statement right here. And so then we come in here and say if LED1 state, basically if LED1 state is true, then come into this if statement. If it's not, then come to this else statement. And so if it's true, then that means the LED is on, and we need to turn the LED off. So we're going to turn LED1 off. And so now since the LED1 is off, we need to make LED state false, because now the LED is off. And so if LED state is false, basically if it's off, then we come into this else statement, and we do digital write LED1 high, basically turn LED1 high because it's off, so we need to turn it high. And then we're going to turn LED state to true because the LED is now on. So then we say LED1 last action equals millis. So this is updating the last action, just saying the last time we have done something with the LED. Since we have turned the LED on or off, now we need to update the last action variable, and then we need to get out of this if statement, and then we need to wait until another 250 milliseconds pass, and then we can come into this if statement and do it all over again. The same thing with down here, everything's exactly the same. We just say millis minus LED2 last action is greater or equal to LED2 DT. And then we just say if it's on, then turn it off. And then if it's off, then we turn it on. And then we update LED2 last action. And so that is everything with the code. And so now we can go ahead and update this, and these two LEDs should be blinking at different speeds. Okay, so now here's the project. As you can see, one LED is blinking faster than the other. This LED is blinking really fast. This one's blinking really slow. And this would not be possible with just using the delay function. These would be both like blinking in the same speed. But since we're using millis, this is easily possible. But with the delay function, this is just out of the question, would not work. And so yeah, this is the project. And so now I'll go ahead and move over to some other things that we can do with the millis function. And so now you just saw a simple example on how you could use millis to do multiple tasks at the same time. And now I want to go ahead and discuss on how you can deal with the millis function overflow. Now, you may be wondering, what is that? I first have to explain what the millis function does when the number gets too high. So basically, the millis function, as you see, the number gets really, really big very, very quickly. In 49 days, the millis function would do something called overflow. Okay, because the value gets way too big that the Arduino is basically not able to store such big number into an unsigned log variable, so it overflows, making it go reset and go back to 0. So now you may be wondering, like, okay, well, if I have a project it's working over 49 days, running over 49 days, then it's going to overflow. How do I deal with that overflow? Well, actually, this project would not even have any issues with that overflow. Okay, let me explain. And so let's take this for example. Let's say I forgot the maximum number that an unsigned log variable can take until it overflows. But let's say it's like I thought it was like somewhere around the 2 million or something. Let's say it's like 2 million and it's about to overflow. And so this is the last time it's going to go into this if statement. So millis is equal to 2 million minus the last time we've been into this if statement and did something with the LED, and we check if that's greater or equal to LED1 DT. Okay, it is. So we would come into this if statement, we do it all, and then we come in here and do all this, and then we make LED1 last action equal to millis. Okay, so the millis comes out here, and meanwhile it's out there, it overflows. Okay, so what happens is, let's say now millis is equal to 0. Okay, so 0 minus 2 million, that's going to give us negative 2 million. Okay, and LED1 DT right here, 250 positive, is greater than minus 2 million. And so it's going to go ahead and go into this statement. Okay, because if we subtract 2 million from 0, it's going to give us negative 2 million. And so LE1 DT is going to be greater. And so it's going to come into this if statement, and then it's going to make last action equal to millis. And then it's going to be equal to, let's say, 0 or 1. And then this is going to reset again. And then it's going to be put to like 0 milliseconds or 5 milliseconds. And then it's going to come back up here, and it's going to say last action. And it's basically going to restart. Okay, it will still work even when it overflows. Just the only thing is that once it overflows, right when it overflows, the first time it comes through this for loop, it's going to go into it. So when it overflows, it may go into this function quicker than it's supposed to, but that's only every 49 days. So yeah, hopefully you understand that's how it can deal with the millis overflow. Okay, so now here's some more code demonstrating how to use the millis function. What this code is going to be doing is it's going to be acting as a countdown timer. And so it's basically just going to be counting down 10 seconds, and then it's going to stop at 0. And so basically that's what this code is doing. And so let me go ahead and explain it. So here we have int timer equals 10. So basically putting the value 10 into the variable timer. This is going to be how much time we need to count down to 0. And so basically it's 10 seconds. So we just need to count down to 10 seconds, and then the timer can stop. And so that's what the timer variable is for. So now we have two unsigned logs here, and we have last time. This is going to be holding the time on the last time we have subtracted 1 from timer. And so now we have no unsigned log, and it's dt. This is basically how long we should wait every single time we decrease timer, the timer variable. And so since we all count down by seconds, we'll count down 10 seconds. So we need to put in 1000 milliseconds, which is a second altogether. Then we come to the void setup, and we just set up our serial model because we're going to be printing out the countdown on the serial model. So then we go into the void loop, and we go ahead and print out timer. So it's going to be printing out the current value of the time that's counting down. It's going to be printing that out, and it's going to be printing out as fast as it can. Okay, so now we're going to this if statement, and we say millis minus last time. Y'all familiar with this? We've explained about this before. And so it's basically giving us the time of the last time we have been into this if statement, and that time needs to be greater or equal to dt. Okay, so if that time is not greater or equal to dt, not enough time has passed since the last time we have been into this if statement. But if it is greater than, if it's greater or equal to dt, then we know that we should go in there, because the proper amount of time, which is 1000 milliseconds, has passed. So we need to come in here and we need to subtract 1 from timer, the timer variable, which we see here. And so then we say, and basically, and this has to be true as well. This statement has to be true as well for us to go into this statement. So this statement has to be true right here, and that's what these mean. And this statement has to be true, which is timer is greater or equal to 1. Okay, because we don't want the timer to go down to the negatives. We just want it to stop at 0. And so we're going to say if it's equal, and if it's greater or equal to 1, then come into here. But if it's 0, for example, then it's not going to come to this if statement. It's not going to subtract 1 from timer because it's less than 1. So now if this statement is true, then we're going to come in here and we're going to subtract 1 from timer. And then we're going to say last time equals millis. And so this is just telling the last time that we have subtracted 1 from timer. So we know when 1 milliseconds have passed for us to come in here and subtract 1 from timer again. And so now we'll go ahead and upload our code and see what the project's doing. So now I got the code uploaded, and so now we can go ahead and press serial monitor. As you can see right here, it starts at 10 and it just starts going counting down, as you can see, and it's printing it out the same number out multiple times. It's demonstrating that we can be doing other things really quickly while we're counting down this timer variable. And so yeah, that is based on the code. And so yeah, okay, so now you know multiple ways on how you can use the millis function to do multitasking and non-blocking code. So yeah, if you love this video, consider giving this video a like. Also comment down below if you have any questions, and consider subscribing if you want to see more content like this. Thank you all. Have a great day. Bye.